In this session, we will just want to look at function notation and function evaluation. Function notation and function evaluation. So function notation and evaluation. So if we recall, a function is just a special kind of relation. Okay, so recall that a function is a special kind of a relation. And what we got was that a relation is a set of ordered pairs, a set of ordered pairs of the form x comma y. Now this function, which we say is a special kind of a relation, is a process. So a function is a process by which the elements of the domain, remember we're talking about the inputs, map with elements of the range, which we call the outputs. Now, we also realize that the range which I'll use y, is dependent on the domain, which is, let's say, x. Okay. What that means is that if we know the value of the domain, if we know our input, that is going to help us find our output, which in this case is the range. And so we have a name for that. So the range, which is y, is said to be the dependent variable. Dependent variable, because it depends on the domain. And the domain, which is x, is what we call the independent. The independent variable. Now, this process, that links or associates the domain to the range or that maps the elements of the domain to those of the range. This process can be denoted by letters. Okay, so let's put it this way: the process that associates elements of the domain with elements of the range can be denoted by letters. By letters such as F, G, H, etc. And so by way of a sketch, if I have something like this, this being my input, or better still, the domain, that being my range, or the output, assuming that I have this X in my, or this element which is X in my domain, which has to map by a process F. Okay, so this process, or this letter, takes X, takes this elements of this domain and map to an element here. So this is Y equal F of X. Okay, so this is how we represent that. So this process, this function, takes this element here, and then it maps to an element in the range. This is the idea of function notation. The above sketch gives us an idea of function notation. Okay, so you see that we can define a situation like F such that X maps to Y. That is exactly what this sketch is all about. So there's a process, which is this F, which is a function that takes this X and maps it toward this Y. And again, note that this X there is nothing more than the input or the domain. And that is your range. And this is just a function. Okay, so this is a function, or that process that links the X to the Y. Okay. Now, that can equally be written in this form. This implies we can write this as this. Okay, and it's the same stuff here. And what that means is that the value that Y takes is dependent on the value of X. whatever this y value is going to be, which in this case is coming from the range, whatever this range value is going to be is dependent on the value of x. So let me put it this way. So note that the value of y is dependent on the value of x. Okay, and that is the main reason why in the beginning we said that the y is said to be the dependent variable, and then the x is the independent variable. Okay, so we have established a situation where we have that. So we have a process, this function, taking what? An element in the domain and mapping it to an element in the range. So whatever you see here is from the range. Whatever is kind of inside the parenthesis is from what? The domain. Okay. Now note that this whole thing here is read as f of x. This is how we read it. So this is basically f of x equal y. Or sometimes we can also read or read as the value of the function at x. The value of the function at x. In other words, the value of y, or the value of the range, given that x value is known, given that the input is known, given that the value in the domain is known. Once the value in the domain is known, once the independent variable, the value of it is known, you should be able to establish the value of the dependent variable. A very typical example is f of x equal, let's say 2x squared minus 2x. Now, when you see this, this is a function notation. This is basically what we call a function notation. This is a function notation. Okay. Where this is the domain, an element in the domain, and everything here is going into your range. So just like we see it here, it is the same preamble. There's a process, which is a function, that takes every element in the domain and maps it onto every element in the range. And so if you have a situation like that, it is self-explanatory, is the same thing. There's this process f, which is a function that takes an element x from the domain and maps it to what? An element in the range, which is defined as what? X squared minus 2x. So what that means is that if I knew the value of x, which is going to be my input, I should be able to find the value of my output just by what? Plugging it in. Okay, so that is exactly what a function notation is all about. Now, when the value of X is given and the value of Y can also be found. Simply that, okay? Without that, we can't do anything here, okay? If you are just given this without, and they ask you to evaluate without, you know, any value or any expression replacing X, we cannot do that, okay? So that's what it means to have a function notation. Now, if we now know what a function notation is, then we should be able to evaluate functions. So let's look at evaluating. Functions. So how do we evaluate a function? It is pretty simple. Of course, I want to believe that you've gotten what I explained there. You got to know what your input is. If you know your input, you should be able to get your output. So let's put it this way. A given function in F, it could be G, it could be given G, it could be given H, you know, etc. May be evaluated at different values of the independent variable, which in this case I'll name it as X, by substitution. By substituting. Okay. And when we say by substitution, simply put, just plug in the value of X into the given function, and just evaluate. That's it. So without any input, you cannot find any output. Without any value of the independent variable, you cannot find any value of the dependent variable. So it is very, very, very clear. I want to believe that this is self-explanatory and we can all do this. Let's take an example. Write a function and evaluate at X equal 3. Okay, so write a function and evaluate at X equal 3. And when it says write, it's giving you this. X is subtracted from 5 n squared. N squared. Okay. So that is the question. It says write a function. Now you know that functions are notated by letters. You can use F, you can use G, you can use H, what have you. So I'm just going to use F. So I'm going to let F as in the function of X be my function. Okay. So if that is the case, then my F of X is going to be, now I'm going to read, it says X is subtracted from 5, n squared. So from means that the 5 has to be on the left, the X on the right with a subtraction, and then everything squared. So that would be your function. X is subtracted from 5, n squared. So now that I have my function, it says that I should evaluate at x equals 3. So that means at x equals 3, I just plug it in. It's going to be f of 3. Wherever I see x, I plug in what, 3. So it's going to be 5 minus 3 all squared. Now 5 minus 3 is 2 all squared. Remember, this is 2 times 2. And that gives you 4 as your answer. So situations like that, you should be able to do it. Let's talk about another example. Given the function f of x equal 5x squared minus 8x plus 7. It says calculate the following values. We have 1, f of negative 2, 2, f of negative 1, 3, we have f of 0, 4, we have f of 1, and 5, we have f of 2. So look at it carefully. The function notation has been given. Better still, the function is given as f of x equal 5x squared minus 8x plus 7. Remember that that is your input. And everything here is going to be your output. And again, if you know your input, you should be able to get your output. Okay, so the first one says f of negative 2. What does that mean? It means the function has to be evaluated at x equals 2. The function is evaluated at x equal negative 2, right? X equal negative 2. Okay, so all that you do is you go to the function and plug in x with what, or for what, or by -2. So this is going to give me f of -2 will be equal to, wherever I see x on my right hand side, I plug in -2. So this is how you see it: 8, -2, and then plus 7. You can grab your calculator and evaluate this easily. You shouldn't go wrong with your calculators. Let me go to another page and then we continue from there. So we have f of -2 giving me basically 5 into -2 all squared. Just rewrite it again: 8 into -2 plus 7. Okay, now -2 squared means -2 times -2, and that should give you 4 positive. Remember that there's a minus here, there's a subtraction here, and this value is also what, negative. So 2 negatives will always be a plus. So first off, this is what you see. Then 5 times 4 gives you 20, plus 8 times 2 gives you 16, plus 7. And then you can go ahead and add. So 20, 16, and 7, when you add up all together, that will give you 36 and 43. You're all set. So that means that f of -2 is 43. In other words, what it says is that when x is -2, the function value is 43. So let me put it this way. That is, when x is -2, the function value mostly the function value is the y is equal to 43. That's what it means. Let's go ahead and do the rest. So the second one, we are looking at f of -1, and it's the same process. I'm going to go back to the equation, which basically is a function, and I plug in -1 for wherever I see x. So it's going to be 5 to -1 all squared minus 8 into -1 plus 7. Remember that the function is f of x equal 5x squared minus 8x plus 7. This is what we're working with. So take note. Just circle it so you know. This is what we are working with. Okay, so just replace the x with whatever value you see here, and this is what we have. Remember, anytime you square a negative, it's always a positive. Okay, so that will give me 1 here. 2 negatives will be a plus 7. That will give me 5 plus 8 plus 7, and the result, we add all together, that should give you 20. And that's it. 3. We have to find f of 0. It's the same thing. Remember, we are using the same function here, and we are replacing every x there with the number given sort of in parentheses. So it's going to be 5, 0 squared minus 8, 0 plus 7. Remember that when you square a 0, it's 0, and when you multiply any number with a 0, it gives you 0. So this is going to go to 0. This is going to go to 0 plus 7. 0 minus 0 plus 7 is going to be a 7. And then we have the fourth one. says f of 1. So the same thing, I'm just gonna plug in for x1, right? So it's gonna be 5 into 1 squared minus 8 into 1 plus 7. 1 squared is 1 times 5 is 5. 8 times 1 is 8, but it's minus there, so it becomes a minus 8 plus 7. So what we do is we just evaluate. You can use your calculator if you want. 5 minus 7 will give, 5 minus 8 gives you -3, and -3 plus 7 gives you 4. And then the last one, you have f of +2. And again, it's the same process. I'm just going to replace the x in the function with a 2. So it becomes 5 into 2 squared minus 8 into 2 plus 7. 2 squared is 4. 4 times 5 is 20. There's a minus here. This is not a minus, it's positive. So 8 by 2 will give me 16. And then the subtraction or the minus will stay as is, plus 7. Then what I'm going to do is I'm just going to go ahead and subtract and add. 20 minus 16 is 4. And I add 4 to 7 gives me 11. And now I'm done. So that is how we evaluate functions easily. Again, you got to be given the input. You got to be given the value of the independent variable, plug it back into the given function, replace it, use your calculator, and evaluate. Simple as that. Let's do one more example. Question says, let g of t equal t over t plus 1 minus 2. And then it says, find the following. Okay, this is a function. Okay, but this notation here is g. So g is a function of t. G is a function of t. Okay, where t here is the input, and everything here is the output. So the output is what, t over t plus 1 minus 2. That's the output. And the input is 2. So anytime I plug in something here, that has to reflect here and there for me to be able to evaluate. So let's talk about the solution now. Find the following. Oh, find the following. Let me finish with a question. Find the following. So the first one, A is f of 10. G of 10. I'm used to f. G of 10. And B is g of -2. C g of 1 over 10. And the last one, D, is g over -1 over 5. So let's go ahead and try to evaluate these here. Okay, so what I know is my function is g of t equal t over t plus 1 minus 2. Okay, And so if I'm looking for the first one, basically g of 10 means that I'm evaluating the function at where t equal 10. Okay, t equal 10. So the input, which is t, now is being replaced with what, 10. So I go to my right-hand side and do the same thing. Wherever I see t, I put in what, 10. So it becomes 10 over 10 plus 1 minus 2. So that would be 10 over 11 minus 2, right? So here is a case where I need to apply a little bit of a fraction idea. So what I can do here is I can divide this by 1. You can always divide a whole number by 1. It's still going to be the same. And I'm going to get the LCD. The LCD of 11 and 1 is 11. So again, I make sure that I change denominators to the LCD. So this is still going to be 10 over 11 minus. If I'm going to change 1 to 11, I need to multiply. And as fraction, whatever you do to the denominator, do to the numerator. So this is going to be 2 by 11, 1 by 11. Okay. And 10 over 11, now that becomes 22 over 11. And once they have the same denominators, keep denominator the same, and then subtract numerators. So once you do that, it gives you negative 12 over 11, and that will be your answer. Done. Let's go ahead and do the others. We have g of negative 2. So g of negative 2. So there's the second one, b. So it's also replacing the t there. So it's just going to be negative 2 plus 1, and then minus 2. Okay. So all that I do is I try to evaluate the denominator. Negative 2 plus 1 is negative 1. And you'll find out here that we have 2 negatives. So when we divide 2 negatives, the result will be positive. But then 2 over 1 is also 2. So everything here is going to be 2. And then I subtract 2. And my result will be what? 0. That's all. Done. In the C part, I'm looking for g of 1 over 10. So again, wherever I see t in the function, it is replacing it. Okay, let me put it here. Remember that the function is what? G of t, t over t plus 1 minus 2. So this is what we're using to do our evaluation. So now that I have 1 over 10, what it means is that the t is being replaced by 1 over 10. So wherever I see the t on my right-hand side, I'm going to change it to what? 1 over 10. So here we go, 1 over 10. Okay, so let me put it this way, divided by 1 over 10 plus 1 minus 2. So look at it carefully, carefully. This looks a little bit cumbersome, but it is still doable. You got to be patient with it. Mostly this is what we call the complex fraction. So you want to look at it carefully. So I'm going to go step by step. 1 over 10, that's for the numerator. For the denominator, what I can do is, if I take the parenthesis here off, then I'm going to have 1 over 10 plus what? 1. And, 1 is the same as I write 1 over 1. And so from here, something like that. This is minus 2. So something like that, right? And if you look at it carefully, then the LCD of 10 and 1 is going to be 10. So I can change this to what? 10 over 10. So I can simply do that as 10 over 10, right? And then once I do that, I should be able to evaluate the denominator easily. Let me push it here, equal 1 over 10 over, because now the denominator is 10, I keep it same, and I sum the numerators, it's going to be 1 plus 10, and then I subtract my 2. So let's go to the next page, and I'm going to continue from there. So f of that, we got 1 over 10 here, and then we had 1 plus 10, and then minus 2, okay? This is what we had in the previous page. So this is now 1 over 10, and then this is going to be 11 over 10 minus 2. So take note, the whole of this, if I add the numerator, becomes 11, and I divide by that. So what I'm doing here is I'm trying to evaluate this, and then finally I'll subtract 2 from my result. Okay, so how do we do this? It's simply rewriting it. If you have a case like that, you can rewrite it as 1 over 10 divided by 11 over 10. It's just simply that, minus your 2. Okay, so don't freak out if you see a complex fraction like that. You can rewrite it this way. And remember what we do with division, we always change it to multiplication, and then we flip the fraction on our right hand side. So when we flip it over, it's going to be 10 over what? 11. And then minus 2. And then all that we do is we check to see if we can cross stuff out or reduce the fraction. And then after we are done that, we just multiply across numerator, denominator, and we are done. So I can cross out this 10 here and that 10 here, and I'll be left with 1 over 11 minus 2. Again, this 2 is a whole number, so I can divide this by 1. And once I divide by 1, I need to get an LCD. The LCD is going to be 11. Okay, here the LCD will be 11. So what I need will be to change the 1 to 11, because it's already 11. I hold that the same. So it's going to be 2 times 11, and then 1 times 11, just so that I will have the same denominators. So 1 over 11 minus 2 times 11 is 22, all over 11. And from here, I hold the denominator the same, 11, and then I try to subtract the numerators. And that should end up giving you 1 minus 22 is negative 21. And I divide by 11, and that is that. So it's a little bit cumbersome here because you're dealing with a lot of fractions, but the process is still the same. Plugging in what you know or what you've been given, and patiently, trying to evaluate what you have by way of, put in all the resources or the previous knowledge, and then try and evaluate it. You can use your calculators to do that if you want to. Let's look at the last one, which is the D part. It says find G of -1/5. And again, this is a fraction. Remember that we're still using this G of T equal T over T plus 1 minus 2. Okay, so that's same thing that I'm doing with the last one. And then -1/5 is replacing the T in all cases. So -1/5 divided by -1/5 plus 1, and then minus 2. So it's the same idea, same approach. So -1/5. Here I need to evaluate the denominator. 1 is the same as 5/5 because the denominator here is 5. I can rewrite this as 5/5. Okay, just so that I can easily evaluate. So -1/5 in the numerator. This time I have the same denominators. I keep that and I try to sum up the denominators. So I get this -2. And then here we go again. The numerator is -1/5. And then I try to simplify the denominator. This was just going to give me -1 plus 5 is 4. So I'm going to have 4/5. And then I subtract 2. And this is exactly what happened in the previous case. You can rewrite this as -1/5 divided by 4/5. Okay, and then you subtract your 2 here. And what that means is that we are changing the division sign to multiplication and flipping this over. So 5/4 minus 2. And then we check to see if there are similar items that can cross out. For this here and that here cross out. So you'll be left with -1/4. And then you're going to subtract 2. But again, this 2 I can divide by 1, which means that the LCD is going to be 4. And once I do that, I change the denominators to 4. So this by 4, and that also by 4. I don't change this because it's already my LCD is already at 4. So -1/4 minus 2 by 4 is 8. 1 by 4 is 4. So I see we have the same denominators. I keep that the same as 4. And then I'm going to subtract the numerators. As I do that, I have my answer. -1 minus 9. Minus 8 is minus now. I'm almost telling you the answer. Divided by 4, and that is what the answer is. And again, note that if you have a fraction and one of them, either the numerator or the denominator, is negative, it's not really so. That negative is affecting everything there. So mostly you will see the negative sign in the middle, something like that. If this is right, this is right, but just that preferably this is what we write. Okay, so that is how we evaluate functions. Let's do 2 more and then I'll end the video here. So let's look at this example 2. Given that h of x is 8x squared plus 6x plus 6. Evaluate h of -5. And this is a very simple one. Again, look at the way this function is defined. It is notated as h. So it could be given in any form. It could be given as an f of x. It could be given as g of x. It could be given as h of x. It could be given anyhow. You just have to use exactly what is given to you to evaluate. So I know that the function h of x is defined as 8x squared plus 6x plus 6. Okay. The question says find h of -5. And what that means is that it is saying that the input x has been given to you and you are to find the output. Remember that the whole of this expression, 8x squared plus 6x plus 6, is going in for our output, is representing the output. So given the input x to be -5, we are going to our output, and wherever we see x, we replace that with what? -5. So this is going to give me 8 into -5 all squared plus 6 into -5 plus 6. You don't see any x here, so that is maintained. So that will be 8. Remember, -5, anytime you square any negative value, it becomes a positive. Here it's going to be 25. Okay. And a positive and a negative will always give you negative. So 6 times -5 gives you -30. And plus 6. Then we want to multiply 8 by 25. If we have 25 by 4 gives you 100. And so if it is 8, it should be 200. Okay. So 8 by 25 should give you 200. Minus 30 plus 6. So subtract and add. So 200 minus 30 is going to give you 170. And then 170 plus 7 gives you 176. And you should be all set with that. So let's look at this last example here. Says the graph below shows the function y equal k of x. So basically, k there is the process, is the function that maps what? The input, which is x, to the output, which is y. So this is the graph of this function here. And the question says that use the graph to calculate k of 2. K of -2 plus k of 2. K of -2 minus 2k of 0 over what? -3. Okay. So we're going to be using the graph to evaluate. Okay. So what is k of 2? Okay. Now remember back in the other video, we realized that if k is the function, then whatever that we see, whatever value we see here as in the parenthesis is representing the input. Okay, it's representing the input. Now we understand that the input is from the domain, and in terms of variable, because we're talking about a graph, we know that it's what? X and Y. Now the X there stands in for the input, or it is an element of what we call the domain, okay? So this here tells me that X is 2, okay? So I go to the X value and then locate what? 2. And what is going to be my Y? Okay. Now, this graph is not really drawn to scale, but you will see that the 2 is somewhere here. 2 is somewhere there. Okay, this is a 2 for X. So if the 2 is exactly on this line, this is what we call the X-intercept. This is the X-intercept. So if for X-intercept, we have an X value, its corresponding Y value should be 0. So this one is going to be what? 0. So take note. So that's the first one. The second one is we have to find K of -2 plus K of 2. Okay. So again, we know of what? K of 2. K of 2 gave us 0. What about K of -2? So we still on the X. Remember, the K of -2 tells me the X value is -2. So I locate the X value. And then what I do is I try to what? Move from that value up to touch what? The graph. And whatever value I can read off for Y is going to be the K of 2. Here, there's a 6 there. So that tells me that the K of -2 is positive 6. So this is actually what? 6. And that is what? 0. So together, this will give me 6. Okay. Then the C part, it says I should find K of -2 minus 2 of K of 0 all over -3. I already found K of -2 here. K of -2 is 6. So 6 minus 2. What is K of 0? K of 0. K of 0. So K of 0 says that I should be on X equals 0. If I'm here, if X is equal to 0, and I move up, the Y value that I touch on this line is 3. So X is 0. K of 0 means X is 0. So you move up to touch the line, which is a graph. And wherever you touch, if you're able to read that value there, that is your value, or that's your answer. So that will give me a 0. That will give me a 3. Okay, X is 0, but the Y value is a 3. So that will be a 3 here. And then divided by -3. So if I evaluate, there's going to be 6 minus 2 by 3 is 6. And I divide by -3. And 6 minus 6 is 0. And I divide by -3. Remember that 0 divided by any number is 0. So once again, note carefully that a K of -2, K of -2 is what we found here. Locate the -2 on the X, project it up to touch the graph, move to your right to touch the Y. That value there is your answer. So that is the 6 minus 2. This is the 2. K of 0. Where is K of 0? This is K of 0. That is where X is 0. When X is 0, we project it up to touch the graph. and we see that it intersects the y at this particular value 3. So that's the answer for what? K of 0, and that's 3. So I put it here. 2 by 3 gives me 6. There's this subtraction there. The 6 is also there from the k of -2. And then when we subtract, we get a 0. 0 divided by any number is 0. So this is how, we evaluate functions. And again, a function notation is just a representation of the link or the association between the independent variable and the dependent variable, or in other words, the domain and the range, or if you will, the input and the output. So there's this process that connects them, and the process we denote by letters. It could be F, it could be G, it could be H, and so any of these given, you got to use it as S. It could be given in any form. But the fact is that whatever form is given is telling you that that process or that form or that letter serves as a function that takes every element in your domain to every element in your range. And once you know the value of your input, you plug it into that function, and it will give you the value of your output. So if you don't know the input, you cannot find the output. So make sure that you're doing your calculations correctly. All that you're doing is giving any X value, plug it back into the function, replace every X with that particular value, grab your calculators, be able to calculate them, and that's it. Then you get the answer. That's how we evaluate functions. I hope this video will help you out in doing your homework assignment. Thanks for watching.